Okay, hello guys, and welcome back again to my channel. We have started last time with the introduction to SAP2000, and today we are going to continue with our tutorials. In today's video, we are going to explain how to create grid, how to define the material, and how to define the cross sections of our structures. I found this example. It's gonna be a real example that we're gonna go through. It has all the theoretical calculation and is based on Eurocode. It's an elastic design of braced steel frame building. Also, it's one of the building that is erected in the UK, as you can see. And this is the picture of the structures and the information of the building. We have 21 meters by 24. That is the width, and this is the length, and the total height of the building is 33 meters. Along the length there are 5 bays, each 9 meters long, and across the width there are 3 bays of 6 meters, 9 meters, and 6 meters again. The building is 8 stories. The height of the first story is 4.335 from the ground floor to the top of steel height, and all the remaining stories have the height of 4.135 from top to top. So over the south elevation there is a 2-story ground floor atrium, 9 meters times 8, and each side of the building there is a 4 meter times 4 void to provide fireman access and escape stairways. There is a central lift core. This is the central lift core of 9 meters times 2.5, as you can see in this figure typically. And all the slabs are lightweight composite slab with a thickness of 103 millimeter. So here's, I'll go back again. You can see, let's say we have 21 meters times 45. So this is the total of 45. 1, 2, 3, 4, 5 times 5 is 9 times 5 is 45. And we have here 12 plus 9, that is 21. Yeah, 21 here. So we have 5 bays and 3 bays as it's mentioned. In the horizontal direction we have axis 1, 2, 3, 4, and in the vertical direction we have axis A, B, C, D, E, F. So this is the grids that we are going to define in SAP2000, and this is the floor plan for 3rd floor to 7th floor. But for the second floor, or for the first floor, actually this is the first floor, I mean not the ground floor, the first floor. The structure, it is given here already. We have this other representation here. So now we are going, this is also the plan for the second floor. This is the plan for the first floor, and this is the plan for the second floor. Now we are going to start, we are going to open SAP2000 and try to model this information into SAP2000. So last time, as I was explaining, when we open SAP, we don't have any informations. The menu bars are all deactivated or in gray. Only the files, new, model, and open are activated. Tools and help menu bar are activated. So we click on new icon here, and this new model will pop up. The new model will pop up. We select the unit. We select also the code or the country of the material, that is Europe. Yeah, because in the information here we say we are going to use the materials European material. So yeah, and We are going to select grid only because we want to define the grid of our structures. So as basic, we can just make, we know that in the X direction, we have how many grids? Let's count. In the X direction, we have 1, 2, 3, 4, 5, 6. So we have 6 grids in the X direction, and in the Y direction, in the X direction, we have 6 grids, 1, 2, 3, 4, 5, 6. And in the Y direction, we have 1, 2, 3, 4. And the intermediate, but this one we can define them later. This is not a big problem. So we have 1, 2, 3, 4 grids in the Y direction, and 1, 2, 3, 4, 5, 6 in the X direction. So we have here 6, we have 4, and how many directions we have? In the Z direction, that means actually the height of the buildings. Yeah, as I was saying, the building has 8 stories, so we have 1, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so 9 axes. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 axes in the Z direction. So here we have 9 axes. So in the X direction, the span, the grid span, the spacing between each grid is 9,000. Yeah, that was here in the 9,000 or 9 meter. And in the Y direction, since we do not have the same spacement, the first floor has a different spacement, and the remaining floors or the remaining stories, they have all the same spacement. So we can first define the spacement for all the floors is equal, and later we can edit them or we can modify. So we are going to make all the height, all the floors 4.135 meters. That is 4135. No, sorry, this is for the Y direction. My bad. Yeah, for the Y direction is 6, 9, and 6. So it's not the same, so let's make it first 6 and later we can edit. But for the Z direction, that is the height of the building, we have 4135. Yeah, when we click OK, then yeah, this is our building, and here we can see the elevation. If you want to zoom, you can use the mouse wheel to zoom in and zoom out. But if you want to pan, you just hold the mouse wheel and then you can pan the model. But if you want to rotate, you hold Shift and the wheel, the middle bottom of the mouse, and then you can rotate. So if I rotate here, I can rotate anyhow. So that's it. So here we have two views. We have the plan view and we have the 3D view. Here we are in Z equals 33 meters, I think, almost. But we can change between views of this by clicking here. Actually, we can click on one plan here also, because this is the plan that was activated. We see here we are in the plan XZ, but Y equal to 18. This plan here that is highlighted in this view, and we can change by going to clicking here. Then we can shift between view by just clicking on the view. Once you click on the view, this view become activated. Once you click here, then this view become activated. Then we want to go in YZ direction, we can go in X direction. That is the plan. So if we want to, we know that this is 6 meters, this is 6 meters, and this is 9 meters, and this also 6 meters. But when we were defining the grid, all of them were the same spacing. So we need to modify. How do you modify? You just double click on one of the grids the intersection of two grids. Yeah, edit grid, or you can just double click on it, and then this is gonna pop up, and then you can modify. In the modification area, where do we want to modify? We want to modify in the Y direction, because that is where there is a difference, and this is the Y direction. You see here is coordinate. That means from here to here, this is 0 coordinates in the Y direction. This is 6,000, and then 6,000 plus 9,000, which is not 12,000, actually it is supposed to be 15,000, and 15,000 plus 6,000, or 6 meter, that is 21,000. Yeah, that is it. So we already modify this place, and if we click on OK, we can see here it has changed. This one didn't have any problem, it was 9 meter and so on. But we need also to change from the first floor. You know that the first floor is different. The first floor is 4.335, but currently it has the height of 4.135. Same way, we just click on this, right click, edit grid, edit grid, modify or show system, and then we are in the Z direction. We can see here it's not 4, this one is supposed to be 4.335. Enter. Okay, but you see it will affect this one. If you click on OK, you will see that it has moved up, but this one already now it has changed. If you go to view, measure, line, and you select this point and this point, you find like it's no longer the same dimension that it is supposed to be for one here, because everything has been updated. So we need to go again and modify the grid. Modify. So what we are going to do, we are going just to delete everything, and we are going to add this one by making spacing here to read. Okay, so here's Z1, Z3, Z4. Let me just make Z4, 3, Z4, Z5, Z6, Z7, Z8. Yeah, first Z it's there. This one is you can select all of them, and then you can select all of them, and then 3, right, sorry, 1, 3, 1, 4, 1, 3, 3. Yeah, this is the height. Copy, paste. Okay, I can I copy? If I can copy or not, let me see. Okay, I need just to type them, not a big problem. Yeah, so you can see this is the possibility that we have, that we can edit. So we have how, let's count if we have 8 floor. 1, 2, 3, 4, 5, 6, 7, 8. Now we can click OK. Yeah, now we have first 1, 2, 3, 4, 5, 6, 7. Oh, 1 is missing. One floor is missing. That is add 1. Spacing, I want to see Z9. That is 4.125. Yeah, that's all. So as I was mentioning, like we have our building here in 3D. If I click here 3D, Then I have our building that is here with 8 stories. 1, 2, 3. Okay, let me go plan. XZ. Yes. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And here we can have YZ plan. Everything is given. Yeah, that was the first step. The first step is to define the grid. I've explained how to define the grid. We can just click on the grid and then start editing the grid based on our project. So we can have any project and then you can add and edit them later. So the second step after defining the grid is to define the materials and to define also the cross section. As you can see, the cross section here, all of them are, we have different cross section. Actually we have IP, HEA, IPE, but the steel grade is all the same. So we define first the steel grade and based on Eurocode. So to define the material, we go to define, that is the menu here, define, and then we have materials. At the beginning we have yeah, this one I can still delete them. Yeah, I can still delete all. I cannot delete this one because this is the default material. That is not a big problem. So when we want to define the material, we can add material, we can copy material, we can add a new material, we can add copy of the material. That means if I have this material, I do not want to add a new one, I just want to copy it. I can just click on copy and it will copy this, the properties of this material, and then I can just edit the name. But we are not copying, this is concrete. We want to add steel structure material. Then we have to add a new material. Here is gonna select, is gonna ask us the region of the material. We are going to select Europe. The material type, we have different type. We have steel, we have concrete, we have aluminum, we have cold form, rebars, tendon, and others. So we select this, and the standard, okay, this is the standard. Directly when you select steel, it will automatically pop up here as the standard that is according to this material. If we select concrete, it will change. You see, steel, it was 3, concrete it's 2, aluminum it's just Eurocode, and code form it's 3-1, and so on. It's giving you the grade directly. So we select steel, and this is the grade. We have different grade, but we want to use 355. That is already mentioned in the project. We select our steel grade, and then we click OK. So this is our new material that we are going to use. I can modify by just typing the name, steel grade S355. Yeah, and as you can see, when you want to modify, this is the unit weight. You can change, you can add, and everything. But if we want to make sure that the unit weight is compliance with what is mentioned in this document, we can scroll down. There is a place where, yeah, this is the self weight of the structural elements, including the weight of the steel structure. So the self weight, the software will later calculate the self weight of the element, but it will base it on the structural steel weight. And here you see they consider a 78.5, but here in the software they consider it like a 76.95. So we are just going to say this is 85. Yeah, and this is all correct here. Everything is 5. Everything is, we have the minimum yield stress, and we have also the tensile stress, the expected, and the tensile stress. When we finish, this is the grain. We can change it to anything that we want based on the preference of the user. I can put it maybe in pink. Yeah, then okay, I need also to define another material. They mention here that we have the self weight of the light concrete slab. We have a concrete slab, so we need also some concrete material. New Europe concrete. Yeah, but here is the light one, this one, C12. Okay, so when we check, we can see the unit weight. The unit weight is 12.5. Let's put it at 12.5. 12.5, that is 1.25. Okay, then it's fine. Thank you for watching and see you in the next time.